Hello everyone, I would like to show you a short demonstration of the Half-Life Lab activity you'll be doing today. As you can remember, we ask you to imagine having 100 pennies in hand to toss. I collected 100 pennies and would like to model Half-Life Lab activity today. Here are our materials. As you can see, I have heads and tails information in the cards. First, we will shake our black mug containing 100 pennies. The reason why we shake it, to be able to randomize our heads and tails information as much as possible. We would like to have a large range of possibilities for heads and tails coming up after we pour all the pennies on the table. This is called randomization. As you can see, I have a white mug too. I will use this mug to collect pennies showing tails after each iteration. Let's start the demo. I am pouring all pennies first, which are in the black mug. This is going to be recorded as iteration 0 in our data table because we have not removed any tails yet. This was iteration number 0, where I had 58 number of heads, 42 number of tails. Then I am collecting all the tails and remove them from my batch. I am putting these pennies into the white mug. Then I keep doing similar steps until no tails left to remove from the table. This was the iteration number 1, and I had 34 number of heads, 24 number of tails. And I keep continuing until no tails left. This was iteration number 2, where I had 20 heads and 14 tails in my batch. Now I am again removing the tails from my batch, and I will be doing the mix only with heads instead. So, what does this demonstration teach us about our topic? Think about pennies showing heads as carbon and tails as nitrogen atoms. The number of pennies remaining was the half-life distribution or count of the previous step. When you graph these values, you'll be able to see that the number of heads exponentially drops over iteration time. With the actual Half-Life Lab activity you'll be doing today, we would like you to think about how the rate of change in pennies count could be related to the decaying rate of carbon atoms in nature. Also, we'll be having discussions on the probability of decaying rate of an atom in radioactive decay process.